Good afternoon. We're working on the review for the Math 1314 Test 2. We've worked parts 1 through 5 in the first video, so we're going to pick up here at number 6. Let me see what it says. It's a problem involving function notation. So let me write the problem down, then I'll switch over. Let f of x equal, it's a linear function, negative 4x plus 5. I can't believe I forgot to turn this phone off. I don't know why I can't believe it, but let me do that. There, okay. And they want us to find f of 3m, m like money, minus 5. No, minus 4. Let me switch over now. That's 3m like money minus 4. So we know how function notation works. That says go to your function f, and wherever you see a variable, where you see that variable, you're going to replace it with that red 3m minus 4, and we have a plus 5. And we can distribute the negative 4 to give me a negative 12m. Negative 4 times negative 4, that's a plus 16 plus 5. And we can combine the constant terms to get the final answer, a negative 12m plus 21. For our final answer, negative 12m plus 21. Let's see, where is that? Negative 12. Any questions there? Number 7 then. Oh, it's a piecewise function. They want us to draw the graph. Remember, we don't have a piecewise graphing tool built into this assignment, so graphing the piecewise functions will be handled using multiple choice. Let me write the problem down. This is number 7 here. F of x equals. Okay. It is. We'll use the part x minus 3 if x is less than or equal to 2. And we'll have the blue piece of negative 1 if x is greater than 2. Let me make sure I didn't miscopy the problem. X minus 3. Okay. And there. Here's the function they want us to graph. Okay, they want us to graph this piecewise function. Realize that in this case, the cut point is at 2 on the x-axis. At 2 on the x-axis, that's where the green piece is going to change to the blue piece. So we'll draw our xy grid. Draw our xy grid. Okay. When we're graphing piecewise functions, we're just plotting points, really. But we plot points intelligently. We don't just start randomly choosing numbers to plug in for x. I'll label this first piece 1, and the second piece 2. So I'll make a table of values for the green piece, then I'll make a table of values for the blue piece. So here's table 1. The first number that you plug in for x must be any number that appears within the inequalities. You have to use 2 as your starting point for the x value that you're plugging in. You're using 2. And then you need another x value, one that's actually smaller than 2. Something you could use negative 20 million way out here, but use something easy. How about 0? I have a question. Could we use 3 for the blue piece? I mean, for this green piece? Could we plug in 3 here? Is 3 less than 2? No, it isn't. So you can't use 3 as an x value for the green piece. Plugging in 2, you get 2 minus 3 is negative 1. Plugging in 0, 0 minus 3 is negative 3. For labeling these cut points, use the same rules you use for solution cut points at the beginning of the semester with the cut point method for solving inequalities. This cut point, x can equal 2, so this will be a regular closed dot. A band? No, I don't have a Band-Aid. I'm pretty sure I may have a screwdriver in my backpack. I mean, in my briefcase, but I'm pretty sure I don't have a Band-Aid. No. So, the secondary point, the points that you create yourself or you choose, like I chose 0 myself. 0 isn't a cut point. Those secondary points are just regular closed dots. So you make sure you've labeled 2 clearly on the x-axis. You have the point 2, negative 1. There it is. 2, negative 1. And then you have 0, negative 3, left, right, 0, down 3. The graph starts at the cut point and it goes to the left. Realize this interval never ends. All the x values less than 2, so the left side on the interval keeps going, so the left side of the graph keeps going. And now we're ready for the blue piece. This is piece number 2. I'll make my table of values. The first number, once again, that we must plug in is 2, but x can't actually equal 2. So at this ordered pair, we'll use an open circle. We need another x value that's bigger than 2. Jacob, did you take care of it? Okay. So we need an x value bigger than 2. I think I'll use 3 here. But the secondary points are just plain dots, not open circles. The point that you choose on your own is a plain closed dot. So when x is 2, looking at the blue piece, when x is 2, hey, the y value is negative 1. Notice there's no variable to plug in. When x is 3, the y value is also negative 1. We go to 2, negative 1, expecting to put an open circle there, but we already have a closed circle. So if you have an open and a closed circle appearing at the same spot on the graph, your graph is just a regular closed dot. That open circle says this point isn't on the graph, but yes it is. 2, negative 1 is on the graph. It's on the graph of the green piece. And then we have 3, negative 1. X bigger than 2. On the x-axis, bigger than 2. It keeps going to the right, so the right side of the graph has to keep going. Any questions there? Now let's choose the graph that looks like the picture we just drew. A, no, it's not that one. B, hey, that might be it. Okay. C, no, definitely not. D, definitely not. Response A. Let me move this thing over here. Check answer. Number 8. They want us to evaluate a piecewise function. Let me turn off that. Let me write the problem down. This is number 8. Oh, this is a 3-piece function. We'll use the piece negative 3x minus 20 if x is less than negative 7. We'll use the y value 2 if our x value is between negative 7 and positive 2, including negative 7 but not including 2. And the last piece is x plus 3. We'll use that if the x value is greater than or equal to 2. And they want us to find, let me write this down, they want us to find h of negative 10, h of negative 1, h of positive 2, and h of 4. Let me make sure I didn't miscopy anything before I switch over to my paper. 2, okay, x plus 3, negative 2. Yes. So, okay. H of negative 10, realize the number in the parentheses is the x value. You have to decide which inequality is satisfied with negative 10. Is negative 10 less than negative 7? Or is negative 10 between negative 7 and positive 2? Or is negative 10 bigger than positive 2? Which inequality is satisfied by the x value of negative 10? It's less than negative 7. It's to the left of negative 7, so we're using that black piece. You plug in, replace the x with negative 10. So we have a negative 3 times negative 10. That's a 30 minus 20, which gives me a y value of 10. Any questions there? To evaluate a piecewise function, you first have to decide which piece is satisfied, which inequality is satisfied by the given x value. Looking at the second piece, the second problem, h of negative 1. Our x value is negative 1. Which inequality is satisfied? Is negative 1 smaller than negative 7? Is negative 1 between negative 7 and positive 2? Or is negative 1 bigger than positive 2? It's this one here. Negative 1 is between negative 7 and positive 2. So the y value is, there's no variable to plug in there. The y value is just 2. What about h of 2? Which inequality is satisfied? Which one part allows x to equal 2? Is 2 less than negative 7? What about this one here? Can x equal 2 in this piece? No, because there's no equality bar down there. So it must be this third one. Yes, 2 is greater than or equal to 2. So we're using that blue piece. Replace the x with 2 to get 2 plus 3, which is 5. And h of 4. Which inequality is satisfied? Are we going to use piece 1, 2, or 3? The x value is 4. I agree, we're going to use the third piece. 4 is greater than or equal to 2. So we'd have a 4 plus 3, which gives a y value of 7. Any questions there? Jacob, are you doing yours right now?
Yeah, I'm just trying to figure out, I'm trying to find the page that I wrote the whole thing of vertex, axis, domain, and range.
Oh, okay. I think that's about where we're at. I think that's the next problem.
Yeah,
let's see.
Number 10.
Well, you're ahead of me then. So we have the first one is 10. Then h of negative 1 is 2. H of 2 is 5. And h of 4 we said was 7. Oh, number 9. If an object is projected upward from ground level with an initial velocity of 160 feet per second, then its height in feet after t seconds is given by s of t equals negative 16t squared plus 160t. This is number 9. Let me write this down. The function, this is called a position function. It's negative 16t squared plus 160t. Find the number of seconds it will take to reach its maximum height, and what is the maximum height? Let me see something. Hold on. Let me see something here. We may need our calculator before we're through with this. So I wanted to open up that calculator that I use. Let me switch back to my paper. Here. Okay. Realize t is acting like x in this case, and that s of t is acting like the y variable. The leading coefficient, well, first of all, I see that it's quadratic as a square, so it's either, if we were to graph it, it would either open upward or downward. We can tell by looking at the leading coefficient that it's going to be opening downward. If a is negative, we expect the graph to open downward. If it's opening downward, then there's a maximum value, there's a maximum y value, and that maximum y value occurs where? At the vertex. So use your vertex formula to find the location of the vertex. Instead of x equals, the variable taking the place of x is t, so it's t equals negative b over 2a. Remember that b is the coefficient of the unsquared variable, so that's a 160. So we have a negative from the formula and a 160. The a value, that's the coefficient of the squared variable, so a negative 16. So t is equal, the maximum value is going to occur when t is equal to negative 160 divided by negative 32. Is that 5? Negative 160 divided by, where is it? Negative 160 divided by, wait a minute, turn it on, clear that off. Negative 160 divided by negative 32. Sure enough, that's giving me 5. And that's not 5 feet. That's 5 seconds. That object went up in the air for 5 seconds. It reached a maximum height, and then it started to fall back to Earth. Now, what do they ask for here? Do they ask for the time, or do they ask for the height? I think they ask for both of them. The first thing, the object will take 5 seconds to reach its maximum height. Now, what is the height? Once you know the first coordinate of the vertex, how do you find the second coordinate? You plug it in for the variable. So the height, after 5 seconds, I'm replacing that t with 5. It's negative 16 times 5 squared. I was going to write that just times 25. 5 squared is 25, but plus 160 times 5. I think that looks messy. I better rewrite it. S of 5. It's negative 16. Replace the t with 5. Plus 160. Replace the t with 5. And that'll give us, pulling up our calculator, we'll have negative 16 times 5 squared plus 160 times 5. That's given us a height of 400 feet. So this object went up in the air 400 feet. That's as high as it got, and then it started falling back to Earth. So we go back to my lab, and it's 400 feet. Any questions there? Okay, and next one. Graph the quadratic function f of x equals negative x squared plus 6x minus 13. Give the vertex, axis, domain, and range. I'm going to write this on a clean sheet of paper. Sounds like it's going to be a long problem. So this is number 10. The function we want to graph is f of x equals a negative x squared plus 6x minus 13. And they want us to find the vertex, axis, domain, and range in addition to drawing the graph. Switching over to my paper. I see that this is quadratic. Notice that x squared. That means the graph is going to be a parabola. Look at the leading coefficient. Is this parabola going to be opening upward or downward? The number in front of x squared, I don't see a number there, so what do we assume that a value is?
1.
More than 1.
negative
-1. Okay, it's negative, so I expect my graph to be opening downward. Once we draw the graph, it should be opening downward. Let's use our vertex formula. X equals negative b over 2a. Remember I said it was an easy way to remember that formula. It's the quadratic formula without that messy plus minus square root of b squared minus 4ac. And it's just the negative b, and on the bottom, the denominator of the quadratic formula, 2a. So we've already said a is -1. We should probably write down what b is. What's b? B is the coefficient of the unsquared variable, so 6. So we have a -6. Down here we have a 2 times -1. That's a -6 divided by -2, which gives me an x value of 3. So the vertex will occur when x is 3. What we would do now is make a table of values. I'd plug in 3 for x, and I'd make a note. This is my vertex, because when you're drawing the graph, you'll have to plot the vertex first. And then we'd use another number. I remember saying, don't move more than 2 units away. Normally, I'd like to use 0. But if we do that, that graph may not fit on the grid they give us. So they're not showing the grid. But I think I'm going to use a 1. I think I'll use a 1 for x. That way I'll be sure that this point will fit on the grid they give us in a moment. Plugging in 3, we get a -3 squared plus 6 times 3 minus 13. So we have a -3 squared plus 6 times 3 minus 13. Realize that negative is not being squared. If we'd wanted that negative squared, all that would have to be in parentheses with the square on the outside. We take 3 squared, that's 9, you make it negative. So we have a -9 plus 18 minus 13. -9 plus 18 is 9, minus 13 gives me a y value of -4. There's my vertex. The ordered pair, 3, -4. We need to plug in a 1. Plug in a 1 in for x, we get a -1 squared plus 6 times 1 minus 13. 1 squared is 1. Make it a negative, so -1 plus 6 minus 13. That would be a 5. -1 plus 6 is 5. Minus 13 gives me a y value of -8. So, let's go over to my lab. The vertex is, that was the ordered pair we found, 3, -4. Now they want us to draw the graph. We're graphing a vertical parabola. Even though it's going to open downward, we said it's going to open downward because the a value is negative. It's going to open down. We still use the vertical parabola tool. So if we hover over this thing right there, it says vertical parabola tool. So we click that. We have a vertex at 3, -4. 3, -4. There's the vertex. I click it. Now, these instructions up here, plot one other point. Well, the other point that we found was 1, -8. So let's plot 1, -8. let's see, write one down, 8. Look in that blue box up there in the right hand corner. It says 1, -8. So I know that my cursor is where I want it to be. I'll click it, save it, check answer. They want the axis, domain, and range. The axis is given by this vertex formula here. The axis is the imaginary vertical line that passes through the vertex. Vertical lines have equations in the form x equals a number. In this case, the axis is x equals 3. The axis is given by the vertex formula that we use. They want the domain and the range. The domain I knew the moment I looked at this problem. We said in class, if there's no square roots, that means there can't be any imaginary y values. If there are no fractions, there can't be any undefined results. So if there's no square roots and there's no fractions, what do we assume the domain is unless they tell us otherwise? All real numbers, -infinity to infinity. All quadratic functions have the same domain. So the range, we need to look at the graph. The axis, you have to type it as x equals 3. The domain, parentheses, -infinity, comma infinity. And the range, we have to look at the actual graph. When we look at this graph, let's see if I can blow it up some. There it is. The range is the set of all y values on this blue graph. Does our vertex correspond to a maximum or is it a minimum y value?
Maximum.
It's a maximum y value. The biggest y value on that graph is -4. Notice up here above -4, there's no portion of the graph up there. The biggest y value is -4, and then every number underneath -4, every number less than -4 is used as a y value. It's actually used twice. But so it's from -infinity up to -4. The biggest y value is -4. Remember, when you're typing this interval notation, you have to go small to big. You can't go -4 to -infinity. You have to type. You always put a parenthesis in front of a -infinity, comma, -4. You put a bracket. -4 is used as a y coordinate. There it is at the vertex. That's why you use a bracket. Check answer. Any questions? To determine the range, you have to look back at your graph. Determine if the vertex is a maximum or minimum. If it's a minimum, it'll be that y coordinate. It'll be the y coordinate, every number smaller than it. If it had been a maximum, it'd be the y coordinate of the vertex, and every number bigger than that. Number 11. Okay, we have two functions. They give us f of x is equal to 7x plus 5. They give us g of x is equal to 2x minus 7. And they want us to find f plus g, f minus g, f times g, and f divided by g, and give the domain of each. So let me switch over to my paper. want us to find, first of all, f plus g. Remember we said that that's addition of functions is just algebraic addition. You take f of x, 7x plus 5. And notice I'm enclosing in parentheses to show that f of x, that 7x plus 5 came from f of x. Plus, I'm trying to make that plus red. This red plus is the plus that's right there connecting f and g. So we're adding g of x. G of x is 2x minus 7. And these parentheses are unnecessary. There's nothing in front of that first one to distribute, so that's just going to be dropped. I guess you could say you're multiplying by a positive 1. That doesn't change anything. The second set of parentheses, once again, there's just a positive 1 there to be distributed. It's an unnecessary set, so we just have a plus 2x minus 7. And that gives us a final answer. 7x plus 2x, that's a 9x. 5 minus 7 is a minus 2, for 9x minus 2. For f plus g. Then they want us to find f minus g. F minus g. Subtraction of functions is just algebraic subtraction. You take f of x, 7x plus 5, minus g of x, that's 2x minus 7, that first set of parentheses, it's another unnecessary set. There's nothing there to distribute through. It's just going to stay as 7x plus 5. But the second set of parentheses, it has something in front of it. It has that red minus. Well, what do you do when you have a minus in front of a set of parentheses? The signs inside there, it looks like it was a positive 2x and a minus 7. What impact is that minus going to have? It's going to change that plus 2x to a minus 2x, distributing the negative 1. And that that minus 7 is going to become a plus 7. For a final answer of 7x minus 2x, that's 5x. 5 plus 7 gives me a plus 12. For f minus g. And then they want f times g. F times g. Function of multiplication is just algebraic multiplication. We know f of x is defined by 7x plus 5, and g of x is defined by 2x minus 7. So that's just a binomial times a binomial. 7x plus 5 times a 2x minus 7. What's that going to give us? What are we going to have to use here? How are we going to multiply a binomial times a binomial? Yes, FOIL it out. Okay. So first, 7x times 2x is 14x squared. Outer, 7x times a negative 7, that's going to give us a minus 49x. Positive 5 times 2x, that's a plus 10x. Positive 5 times a negative 7 is a minus 35. Combining like terms, we have 14x squared, negative 49x plus 10x. That gives us a negative 39x. And we still have that minus 35. Any questions there? Don't you just love these problems with all of these parts? A, f plus g, f minus g, f times g. All that's left now is f divided by g. They're representing the division with a fraction bar. That's saying take f of x, 7x plus 5, and divide it by g of x, 2x minus 7. And I think that's it. If there were a common factor we could factor and cancel, we'd do that, but there is no common factor. We're just stuck with this as our final answer. So, let's type in those answers. F plus g, that was a 9x minus 2. F minus g, that became a 5x plus 12. F times g, that's a 14x squared minus 39x minus 35. And f divided by g, I'll use my fraction hot button. And on top, we have a 7x plus 5. And on the bottom, clicking down there, we have a 2x minus 7. And now they need the domain of the four new functions. Let's switch back to my paper. F of x and g of x are linear functions. There are no exponents, no square roots, there are no fractions, so we're not going to get denominators of 0. All we have to do is look through the work. Is there anywhere f plus g, f minus g, and f times g? I'll tell you right now, their domains are all the same. Are there any time in the work where you'll wind up with a square root symbol or a fraction that could give us a denominator of 0? Looking throughout that work, there's no time that you pick up a square root. There's no time that you pick up a fraction. So for these three functions, the domain is all real numbers. Negative infinity to positive infinity. For f divided by g, we'll have to come back to that in a moment. But right now, f plus g, all real numbers, parenthesis, negative infinity, comma infinity. Oh, I should have copied and pasted that because I'm going to have to type it 3 times on it. There. And f times g. Paste that in. Okay. Now the domain of f divided by g. The domain of f divided by g. We've already said these things are slanted lines. Slanted lines have all real numbers for domains and ranges. But when I look at this, we've picked up a fraction. We know that we can't allow a denominator to be 0. So when we're looking at the domain, 2x minus 7 cannot equal 0. The denominator can't be 0 because division by 0 is undefined. That means 2x cannot equal 7, so x cannot equal 7 halves. So the domain is all real numbers except for 7/2. All real numbers except 7/2. So if you were thinking of a number line, there's 7/2. It's not shaded there, but it's shaded everywhere else, all the way out to negative infinity and all the way out to positive infinity. And how will we write that using interval notation? Oh, I think I just have room. There's no closed circles here, so there's no rectangular brackets in the interval notation. You have a parenthesis, negative infinity, comma, 7/2, close parenthesis, union, open parenthesis, 7/2, comma, infinity. Maybe I should be saying right parenthesis, left parenthesis, and right parenthesis. Any questions there? Any questions on our logic? You can't allow the denominator to be 0. X can be anything other than 7/2. Let's type that into my math lab. Then we'll take a break. Because my voice is going out on. Parenthesis, negative infinity, comma, 7/2. Get out of the denominator before I type my right parenthesis. Union, left parenthesis, 7/2. Get out of that denominator before I type my comma, infinity, right parenthesis. Okay. And we're ready for number 12. We'll pick up there in a moment after a short break.